Business Statistics, Chapter 1, Part 2, Sampling. Data is collected from either a population or a sample. The collection of data is an expensive endeavor. Therefore, data scientists use a technique called sampling to reduce their costs. For most statistical questions, we want to learn something about a broad population. A population consists of all the items or individuals about which you want to draw a conclusion. Population is the large group. One way we can learn about this population is to randomly select a smaller representative group from the population. We call this the sample. To visualize the difference between a population and a sample, take a look at the figure. We have a large number of individuals in this population. We could certainly have all these individuals fill out our survey, but that may be too time-consuming and we are on a strict deadline. Instead, we only ask the people shaded in red to answer the survey. Collecting data via sampling is used when selecting a sample is less time-consuming than selecting every item in the population, less costly than selecting every item in the population, and less cumbersome and more practical than analyzing the entire population. Things to consider or deal with in potential sources of data. Is the source of data structured or unstructured? Will the data come predefined, or will you have to clean the data yourself? How is electronic data formatted? Our statistical packages cannot read all different types of data files. We may need to translate or manipulate the file before it can be used. How is data encoded? Once we have the data in our statistical package, how do we know what the variable means? Does the data come with a codebook, which will help us know how the variables are defined and what each individual value represents? Structured data follows an organized principle, and unstructured data does not. For example, a stock ticker provides structured data. The stock ticker repeatedly reports a company name, the number of shares last traded, the bid price, and the percent change in the stock price. Due to inherent structure, data from tables and forms are structured data. However, emails from 5 people concerning stock trades is an example of unstructured data. In these emails, you cannot count on the information being shared in a specific order or format. Another example would be downloading a bunch of tweets from Twitter. You have all these phrases in there and all these bunches of words in there, but there's no set format for them. That's unstructured data. This class will deal almost exclusively with structured data. Data cleaning is often a necessary activity when collecting data. Often, we find irregularities in the data, typographical or data entry errors, values that are impossible or undefined, missing values, and sometimes outliers. When found, these irregularities should be reviewed and addressed. Statistical packages such as Excel, SPSS, SAS, R, Stata, or Minitab can be used to address these irregularities. A sampling process begins with a sampling frame. The sample frame is a listing of items that make up the population. Frames are data sources such as population lists, directories, or maps. Inaccurate or biased results can result in a frame excluding certain proportions of the population. Think back to our example of high school GPA and college students. Using different frames to generate data can lead to dissimilar conclusions. We had one frame where we only considered college students and another frame where we considered all high school students. So how are samples formed? Well, these are the different types of samples. There are two ways you can collect a sample. One, non-probabilistic samples, the wrong way, or probabilistic samples, the right way. Non-probabilistic samples are used out of pure convenience or biased judgment. You may be asked to get the opinion of college students about the upcoming election. So you go outside of your class in the College of Business and ask the students that are there to answer your survey. Sure, you have satisfied the requirement of asking college students, but are these students representative of all students at the University of Louisville? Probably not, but they are convenient. Another method sometimes used is one based off of judgment. Let's suppose you want to gauge the public's opinion on gun laws, so you attend a local gun show and conduct your survey there. There are people of all different backgrounds, genders, and ages there. Is this now an unbiased sample? Probably not, as these individuals are seeking to purchase or trade guns. This sample would leave out individuals who do not attend gun shows or do not care for guns. Types of samples, non-probabilistic samples. In a non-probabilistic sample, items included are chosen without regard to their probability of occurrence. In convenience sampling, items are selected based only on the fact that they are easy, inexpensive, or convenient to sample. In a judgment sample, you get the opinions of pre-selected experts in the subject matter. Now let's move over to probabilistic samples. In a probability sample, items in the sample are chosen on the basis of known probabilities. There are four types used: simple random, systematic, stratified, and clustered. We'll discuss each of these in more detail. A simple random sample is one where everyone in the population has an equal opportunity of being selected into the sample. Think of this system as drawing names out of a hat, where everyone in the population is eligible. Selection may be with replacement, that is, selected individuals are returned to frame for possible reselection, or without replacement, selected individuals are not returned to the frame, so they can't be selected again. Samples obtained from tables or of random numbers or computer random number generators is a way to do a simple random sample. Let's see an example. So an old method used to select a sample is to label each individual in your population with a number. Suppose there are only 850 people in your population, each with a unique number from 1 to 850. We can go to a random number table, often constructed of 5-digit numbers, and select the first 5 entries. Since we only need values between 1 and 850, we will only look at the first 3 digits associated with these random numbers. As long as the 3 digits fall between 1 to 850, we will select that person to be included in our sample. For example, the random number 88924 would be used as 889 in our collection. But since it is greater than 850, we would discard this entry and move on to the next one. A systematic sample is a compromise between randomness and convenience. Suppose there are a total of n people in our population. Let's break down this large group into a smaller group of n people so that you have a total of k, which is equal to the population size divided by these smaller groups. Now, with group 1, randomly choose someone between 1 to n. For demonstration purpose, let's say you selected the second person. Now, for the other groups, just take the second person and include them in your sample. An example of systematic sampling is when people do election polling. Let's suppose you want to know who the next mayor of Louisville will be. You can divide the city into neighborhoods, then randomly select a house number within the first neighborhood. Let's say it is house number 100. Now, You will go to each of the other neighborhoods and visit the first home you find with the house number 100 and ask them your election poll questions. Probability sample, stratified sample. Divide populations into two or more subgroups called strata, according to some common characteristic, race, gender, neighborhood. A simple random sample is selected from each subgroup instead of the entire group, with sample sizes proportional to strata sizes. Samples from subgroups are combined into one, and this is a common technique when sampling populations of voters, stratifying across racial or socioeconomic lines. This technique is used quite a lot when you want to make sure you have minority representation within your samples. Population is divided, when we're doing cluster sampling, population is divided into clusters, each representing a part of the population. A simple random sample of clusters are selected. All items in the selected cluster can be used, or items can be chosen from a cluster using another probability sampling technique. Common application of cluster sampling involves election exit polls, where certain election districts are selected and sampled. Comparing sampling methods: simple, random sample, and systematic sample. They're simple to use, may not be a good representation of the population's underlying characteristics, however. Stratified sample ensures representation of individuals across the entire population. Clustered sample, more cost-effective, less efficient than the stratified sample. How worthy is your survey? What is the purpose of the survey? Is the survey based on a probability sample? Coverage error. How appropriate are your frames? Are you covering everyone that should be involved? Non-response error. Does everyone answer your questions? And if they do, or if they don't, do they do it in a systematic way? Measurement error. Good questions elicit good responses. Sampling error always exists. Let's talk about each one of these. Coverage errors, or selection bias, exists if some groups are excluded from the frame and have no chance of being selected. Think back to our high school and college example. If we don't ask the non-college students, we've made a coverage error. Non-response error or bias. People who do not respond may be different from those who do respond. Think back to if we ask the question of illicit drug users. We believe people say no, but what about the people who don't answer at all? Sampling error. This is variation from sample to sample, and this will always exist. We'll talk about this quite more when we talk about the sample mean. Measurement error. Due to weakness in question design and/or respondent error. Sometimes questions can be confusing and people are not sure how to answer them correctly, so you'll get odd responses. So here's an example of coverage error. We exclude these individuals from our sample, so we may not actually have full coverage. Non-response error. People don't respond to your follow-up questions once they've started to go down maybe a road where they don't want to divulge certain information. Sampling error. This just occurs from the fact that we are taking a sample from a larger population. The larger our sample becomes, the smaller the sampling error. Measurement error. These are bad or leading questions. Sometimes these occur because people just make approximations. For example, when you ask individuals how much money they make, they'll give you a roundabout number, but it may not be the exact number that's actually filed, say, on their tax return, or what their weight is today. Weight is fluctuating quite a bit throughout the day. They may not know their exact weight, but they have some idea of the balance between their weight. So in this chapter, we have discussed the types of variables used in statistics, the different measurement scales, how to collect data, the different ways to collect a sample, and the types of survey errors. In the next chapter, we'll talk about how we can describe data using graphs and tables and charts.